put like sine of 20 degrees in your calculator? Like, do it right now. Do sine of 20. Tell me what you get. And degree mode. Yeah.
0.34.
0.34 dot dot dot, the decimal, right? There are certain cases though where you put sine, cosine, or tangent of specific numbers, and they're actually, I don't want to say rational, but they're not decimal numbers, and we can actually get a nice round number for them. And they happen to be the ones from the special right triangles. So it's 45, it's 30, and 60. So that's what I'm going to show you is we actually can get some exact values, not decimals from these. So here's what you're going to do. Just draw a right triangle. We're going to, so this is going to be the 45, 45, 90. It's not really labeled. So if you want to write at the top, just put like, this is the 45, 45, 91. Your hypotenuse is going to start at the center and go up to, there's overlapping circles, go to any of them. I just went to this one, draw a line straight down, perpendicular, and that will make your 45, 45, 90 triangle. So follow one of those lines on there. You can go to any of the circles. There's 10 overlapping circles. Just choose one of them and then draw a line straight down to make your right triangle. So guys, really what this represents, you don't have to draw in the circle part, but really represents, you chose this circle, I did. I chose that circle. This is, what we're working with is the unit circle. If this circle has a radius of 1, that's the unit circle, then we can get some exact values for sine, cosine, and tangent. So you don't have to draw on that circle that I did. You can if you want, the radius of my circle. But put in 1 here for the hypotenuse. Okay, and from that, I'm going to first solve the special right triangle and then do the trig values. So this is, of course, 90. This angle going up to the 45, this is 45. It opens at a 45-degree angle. And therefore, we can conclude that that is a 45-degree angle as well. Okay, I'm going to solve the 45, 45, 90 triangle. It's x, x, and x radical 2. So I need the legs, and the hypotenuse is 1. What I like to do is I like to set the hypotenuse, the hypoteni equal here, 1 equal to the x radical 2. Or if you just know it's divide radical 2, that's fine. I'm solving for the x, the legs, so I divide by radical 2. Now usually it's a whole number here, right? That's like 6 divided by radical 2. We can more easily divide. It still will work out here. 1 divided by 2, I'm doing the shortcut to rational numbers. It's just 1 over 2, just 1/2. Yeah. Write a fraction, please. Don't do the decimals today. 1 over 2, then you put the radical 2 next to it. Now that is a way to write that, but a better way for what we're going to do as a leg is put this just in the numerator. 1 times radical 2 is radical 2. And so we're going to write each of the legs as radical 2 over 2. That is equivalent, bless you, that is equivalent to 1/2 radical 2. I mean, I could even write the 1 here if I want. So now we're going to do sine, cosine, tangent of those, of 45.
So would you accept like that 1/2 radical 2?
Yeah, but traditionally for what I'm going to do here, you'll see it always written like this for these exact value ones. Yeah, it is equivalent. So now somewhere on the page write sine, cosine, and tangent of 45, like I have over here. This is all we're doing for this, so that there's plenty of room on there. Just somewhere write sine 45, cosine 45, and tangent 45. Okay, and that's what now I'm doing trig. So I'm switching gears here. I'm going to start at, I can start at either 45-degree angle, it doesn't matter. I'm doing trig ratios. I'm not solving for a missing variable right now. I'm just writing a ratio. So let's start here at this 45. I'm going to label this as my hypotenuse. Across from the 45 here is my opposite. and then this side is my adjacent. Okay, now let's do sine, cosine, and tangent. So sine, opposite over hypotenuse, that's radical 2 over 2 divided by 1. Now I'm not going to write the divided by 1 because that would just be radical 2 over 2. Right? Just radical 2 divided by radical 2 over 2. It's divided by 1, that's the same as just radical 2 over 2. Cosine of 45 is adjacent over hypotenuse. Same thing. Radical 2 over 2 over 1. I write the 1. And finally, tangent, TOA, tangent of 45 is opposite over adjacent. What happens there? Yeah, it's just 1. Because it's radical 2 over 2 divided by radical 2 over 2. It's the same thing, so it's 1. You notice the last question from the practice was about that. Why is tangent 45 always 1? It's because it doesn't matter. Whatever triangle you do for that, it's going to be 45, 45, 90. And then because it's isosceles, and so it'll always be 3 over 3, or just the same value divided by itself. So you notice on these, look, if you hit tangent 45 in your calculator, you get 1. If you get cosine 45 in your calculator, you would get this as a decimal. Okay, your calculator can't do, it can't directly write it like that. So, pretty nifty, huh?
Yeah.
Because I mean, basically every other number you put in, sine of kind of any number but these three, well, 30, 60, or the other ones, you're going to get a decimal. But on these, you can actually get more of an exact value. So, by the way, when you do pre-calculus, you're going to see these numbers all the time. You do this thing called the unit circle, and this comes up a lot. They're very important. So, just know you learned it here first. Let's go on to the 30, 60, 90. So, anything I can clarify on the 45, 45, 90? Flip it over, and you're going to just do the same thing as before. I chose to start mine at the 30-degree angle here. Choose one of the circles, start your hypotenuse at the center. You could have put the 60-degree angle at the center. Okay, that would work just as well. Flip it over. What are you And again, you're just going to put the hypotenuse as 1. And I'm first going to do 30, 60, 90, and then we'll do trig. So I'm just putting a diagram up here for 30, 60, 90 triangle. Let's see, so we need to identify, we have 1. That is opposite the right angle. That's the hypotenuse. Okay. I need to get the short leg first. Always go to the x. And so if that's 2x, this is x, this one's going to be half as long. So it's half, yeah. Again, you could write 0.5, but for today, let's write fractions. And that's my x. So this is the long leg over here. It's the x radical 3. So the long leg will be 1/2 radical 3. Right, but just as we did before, you could write it as, for our purposes, it's more traditionally written as radical 3 over 2. Okay, so that was the special right triangle part of it. Now we just, again, do trig. So you'll just have to write down sine 30, cosine 30, and tangent of 30. So let's go ahead and do, oh, I need a label, don't I? Here's my 30. This would be 60, of course. So my hypotenuse is here. Opposite 30 will be over here, and the ADJ here. let's see, so sine of 30, opposite O and H, opposite over hypotenuse, 1/2 over 1, which is 1/2. Cosine A over H, the adjacent over hypotenuse. It's very similar. Radical 3 over 2 over 1. Okay, which is again radical 3 over 2. Tangent of 30 will just require a little work because I want to simplify it. Going to require a little bit of work. Tangent of 30 is O and A, opposite over adjacent. So it's I'm gonna write it out here first and simplify. It's 1/2 over opposite over adjacent over radical 3 over 2. I'm gonna simplify this up. That looks kind of crazy. Do you remember that dividing by a fraction is the same as multiplying by the reciprocal? Multiplying by the I'm into the rhyming thing. Have you ever heard when dividing by a fraction, don't ask why, flip the second one and multiply? No, never teacher said that? Well, basically, if you're dividing by a fraction, you can flip it and multiply. So instead of dividing by this, I'm going to multiply by the flipped version, 2 over radical 3. The 2's cancel, and so I get 1 over radical 3. That's right. I get 1 over radical 3. Now, that's tangent of 30, but that's not in simplest form because we have a radical in the denominator. So we do what we've normally done. Shortcut, 1 divided by 3 is just 1 divided by 3. And then I put the radical 3 next to it. It's multiplying. Yeah, and then the same as what we've done 2 other times here. That is correct, but more traditionally we put the radical 3 in the numerator. So again, 3 more, sine 30, cosine 30, tangent 30, actual exact values. So before I do the 60, which will only take me a second here, any thoughts on the 31? Flipping that, simplifying? You're stretching. Well, I could repeat and do a whole new triangle for the 60. I could also go up here and relabel opposite adjacent and do all that. Or, to get, here's what I'm going to do, to get sine 60, cosine 60, and tangent 60, is you remember how they're related, like cosine of one angle and sine of the other angle? That's all I'm going to do. So I could, if you wanted, you could go back and relabel and it would work. But I'm just going to use the fact that we know this. Let's go. Sine of 30, sine of this angle, how does that compare to cosine of this angle? They're the same. Sine of 30, this angle, is equal to cosine of 60. So 1/2 for the cosine 61. Same thing if I switch up sine and cosine. Cosine of 30 is equal to sine of the other angle, sine of 60. So sine of 60 is the cosine 30, radical 3 over 2. And do we remember what happens with the 2 tangents? Are you answering my question? Yeah. They're flipped. But thank you, they're reciprocal. I can flip any of the equivalent ones. The easiest one is just to flip this one. If I flip 1 over radical 3, it's radical 3 over 1. Now, if you would rather flip this one, it'd be 3 over radical 3. Then you would have to do 3 divided by 3 is 1, and put radical 3 next to it. Still get the same thing. So again, we got 9 values, sine, cosine, tangent of 45, 30, and 60 that are exact values instead of a decimal. So you'll see these a lot coming up in pre-calculus, and it's just nice to see how special right triangles and trig relate.